important result, that is C0 plus C1 plus C2 plus Cn, that is nothing but the sum of the binomial coefficients, that is 2 raised to power n. Let us take one more simple issue regarding this expression. Okay, now I put in the same expression x is equal to -1. Then let me see what I get. I will get 1 minus 1 raised to power n. This is equal to C0 minus C1 plus C2 minus C3 plus C4 and depends minus 1 raised to power n Cn, because it could be minus 1 or plus 1 depending upon the nature of n. When n is even, it is plus, when n is odd, it is minus 1. So, this gives you wonderful information, that is C0 plus C2 plus C4 plus so on is same thing as C1 plus C3 plus C5 and so on. This itself is a important observation and a very nice result, that is the sum of the even binomial coefficient is same as that of the odd one. So, well, I repeat once again, because I took the expression for 1 plus x raised to power n, and with the help of that expression, by merely putting x is equal to 1 and x is equal to minus 1, I got two important informations, that is C0 plus C1 plus C2 plus Cn is equal to 2 raised to power n, and second one was C0 plus C2 plus C4 plus C6 is same as C1 plus C3 plus C5 and so on. And this was the same thing where I used that example, which I simply trivial example, that 4 papers. I gave you this example in the beginning, and of course, in how many ways you can fail. So, that was your basically C1 plus C2 plus C3 plus C4, where in this case my n was 4 and this C0 is missing. So, you apply the formula, the sum was 2 raised to power n. So, this is 2 raised to power 4 and minus 1, that was your 15. So, that was the reason I directly wrote that expression as 15. I did not calculate, because that is a standard result, that sum is 2 raised to power n. Here C0 was missing from here. So, I subtracted that value, which was 1. So, this was the simple solution of the problem which I posed in the beginning. Now, once again, I take the, because I wrote this as very important. Now, I doubt I will ask, of course, from your office. Now, from this expression I gave you two very simple observations, and those who are having just a bit knowledge of differentiation, very elementary knowledge, and that of integration, then you will get plenty of information from this expression. For example, I do not know whether you are having differentiation in your syllabus, but this at least all of you know that I am just writing it for your information. I do not know it is a part of your syllabus, but I am using this 1 plus x raised to power n. This was your C0 plus C1x plus C2x square plus nCNx raised to power n. I differentiate it, of course, so that is n into 1 plus x raised to power n minus 1 is equal to C1 plus 2C2x plus 3C3x square plus nCNx raised to power n minus 1, put x is equal to 1. So, this you will get 2 raised to power n minus 1. You see this expression C1 plus 2C2 plus 3C3 plus nCN. So, this itself is a very important consequence, but I do not know whether this is a part of your syllabus. But this is a very trivial formula, somewhere you use also. Derivative of x raised to power n is very simple thing. So, just differentiating this expression with respect to x and putting the value of x as x is equal to 1, I was able to get a wonderful expression. So, there are number of, let us say, applications of that thing. So, I cannot discuss all of them. I go back to so, I have discussed 1 plus x raised to power n. That is same thing. In fact, this is also a very interesting thing. I have written it in reverse order, whether you write it 1 plus x raised to power n or you write it x plus 1 raised to power n. But you will ask, of course, why we are doing in this way, because this again gives you a lot of interaction between the binomial coefficients. If I will get time, then I will let you know, well, why I am writing this expression, the same expression, in two manners, because this will give you very important thing in the sense, for example, if you just see, you multiply both. So, 1 plus x power n into 1 plus x power n, that will be 1 plus x raised to power 2n. I am not interested in that part, but if you see, you multiply C0 C0, so the coefficient is x raised to power n. Again you multiply from first one nC1, that is nC1x, and from second also x raised to power n. So, you are getting everywhere power as x raised to power n. So, comparing the coefficient of x raised to power n, you will get certain information. So, if I get time, I will explain in next part, let us see. So, this I won't repeat, I have already explained everything. This by using mentally and all those things, there is no problem. These are the properties. Well, you try yourself, because I do not have now that much time. This is simple exercise. And of course, those who are interested, they can contact me at any time. My phone number is with your office. So, these are for, I will definitely like to do this term, that is, what is in fact general term. So, you recall the expression for a plus b raised to power n, and if you take the r plus 1th coefficient, because r plus 1 is important, not You always get most of the time confused with TR and TR plus 1, but just for symmetry this is not rth term, this is r plus 1th term. For example, you have to find out the 10th term in certain expression, then you will write r is equal to, you will take as r is equal to 9. So, this is the formula which will used very frequently to find out any term in the expression of a plus b raised to power n. For example, in the expression of a plus b raised to power n, you have to find out, let us say 101 terms. Then choosing r is equal to 100, you will get the expression for T101. So, R0 you get the first term, which is same as you have already written, second term. So, that was your formula NCA r minus 1 a raised to power n minus r plus 1 b raised to power r minus 1. So, the same thing I have repeated, that T1 you have to find, you have to choose r is equal to 0 and so on. So, sixth term you have to find out in this. So, this is the solution, that is your general term, that is TR plus 1, and in this case is 9. So, that is 9 CR 4x upon 5 raised to power 9 minus r into minus 5 upon 2x raised to power r, but you have to find out 6. Obviously, as I just mentioned, r you will have to choose as 5 and apply your formula. So, ultimately you will simply get it 5040 upon x. So, you can do more examples. For example, find out, let us say I am giving same type of example, power is 10 and you have to find out. So, at least I was. So, T6 is your, I am writing in this way because this is my r. So, formula was your NCR in the expression of x plus a raised to power n. So, NCR x raised to power n minus r a raised to power r. If I choose r is equal to 5, so T6 is T r plus 1, that is 10 C5 x raised to power n minus r. So, n is 10, 10 minus r means 5 into minus 1 upon x, then power 5. I repeat it because in the expansion of x plus a raised to power n, TR plus 1 was your NCR x raised to power n minus r into e raised to power r. Comparing this x and a with the expansion, so this is working as x and this minus 1 upon x is working as a. So, T6 is r I am choosing as 5. So, this is T5 plus 1, which is 10 C5 into x raised to power 5 into minus 1 upon x raised to power 5, and this is very nice expression, they will get cancelled. So, this is, and I do remember it probably, well, you verify, it will turn out because I have not calculated, but 10 C5 it will turn out to be most likely, I am not 100% sure, but you can write down this expression. So, that is minus 252. I am interested in this example from one point of view also, because this is the term which is not containing any x. So, this is a sort of the term which is independent from x. So, this is the way how we find out the formula, how we find out the general term in the expansion of a plus b raised to power n, or for that matter x plus a raised to power n. So, thank you very much. We shall meet next time and we will continue the same discussion.